what I would do on something like this is 20. So even though our first leading coefficient is a prime number, so it's only going to be x or 3x, right? That's the only possibilities for the first terms. Okay, so if you kind of think about that, x and 3x. Okay, the last term's a negative, which means the signs have to be opposites each other. So one positive, one negative. So all of a sudden now you know you're going to have to test multiple combinations of those because the positive could go here or here. Okay, and then 24 is a number that has quite a few factors. So if you were going to test all the different factors, which you could use trial and error, you wind up looking at quite a few different factors that you're going to have to test. So I might consider here trying to rewrite the middle term. Okay, so if I take my leading coefficient times my constant, 3 times negative 24, I have 3 times negative 20 is negative 60, 3 times 4 is negative 12, so negative 60 minus 12 is negative 72. So if I look to see are there any factors of negative 72, okay, whose overall sum is positive 14. Okay, so if I start looking, I have, again, like 9 and 8. Okay, these are opposites. I know since it's a total positive, my larger number needs to be the positive. My smaller number needs to be the negative. So 9 minus 8 gives me 1. I know it needs to be a bigger difference than that. So what you can do is you can kind of start borrowing numbers away from one another here. So if you were to look at something like this, if I take a factor of 2 out of the 8 and move it over here, I get 18 and minus 4. Does this give me a total sum of my middle term plus 14? Yeah. And so I see that my factors are negative 4 and positive 18. And so when I'm working through this, I can rewrite my middle term as negative 4x plus 18x, drop down my first and last terms. And when I do that, I can now factor by grouping. From the first pair of terms, what common factor can I remove? So in this first two terms, just the x, leaving a 3x minus 4. And in my second pair of terms, what common factor can I remove? 6. And that leaves 3x minus 4. If I've done this correctly, I should have a common binomial factor, which I do, and I see it fits the pattern that I'm expecting, 3x minus 4. And then my remaining factors of x and plus 6 are my other pair of binomial terms. Okay. So here is your set of factors. When I use the zero product rule to solve this, what value of x gives you a 0 here? Negative 6. And what value of x gives you a 0 here? The way you can solve it is you can take the opposite of your constant divided by your leading coefficient. So the opposite of my constant is 4, leading coefficient 3, and so those would be your solutions. Now, using your calculator, again, this is one where it would probably be time-saving to do that. If you use the F2 Algebra tab, select Solve, type in the equation exactly as it appears. Bless you. Okay, solve for x, so comma x, close off your parentheses, and when you hit enter, it should confirm 4/3 and negative 6 are the possible solutions here. Okay. All right. For the second example, okay, so once again, it's a graph, but now the graph has rational zeros. So they're not just intersecting right at the grid markings. So it's not as easy to see what the factors are going to be. But you should be able to use the graph to identify the factors and then just use trial and error from there. Because now you don't have to test all the possibilities, because when you look at trial and error here, you know that of these two zeros right here, which one seems the more easier to identify? The positive or the negative? Positive looks like it's where? It looks like it's 1/2, right? This one looks like it's maybe 3/4 or so. Again, you can't really tell. It's just some fraction form, but this one looks like it's 1/2. So let's test and see that factor. The factor that gives us a 0 at 1/2 Remember, when we solved our zeros, we took the opposite of our constant, that's our numerator, divided by our leading coefficient. So what's the opposite of our numerator? -1, and what's our leading what's the denominator? 2 becomes our leading coefficient. So what we're looking at is if we FOIL this, reverse FOIL, and we look at that, could this be one of the factors? If it were, what would the other first term have to be for the first to equal 6x squared? 3x. And what would the last term have to be? +2, right? So let's test this and see. Is the outer plus inner equal to plus 1x? So 3x times a -1 is -3x. 2 times 2x is 4x. Is -3x plus 4x equal to plus 1x? Yeah. So we are able to use the graph to help us decide our trial and error. And so we don't have to test all the possibilities. We can now go straight to our solution. And we can now see 1/2 was correct. And our other rational form is going to be the opposite of our constant, -2, divided by our leading coefficient, 3. And so those would be your two solutions based on that graph, but then again using that information to factor it. Okay. Now if you want to just go straight to the factoring of it, and that's fine too, but you can use the graph, and often it will allow you to narrow down your choices for the trial and error.